So this video reviews perfect competition, doing an application to physician markets, or the physician office visit market in Florida. And to follow along, you're going to need to download the question associated with this that you'll see in the link below. So go below the video and download that if you haven't already. So for this question, we're analyzing the market for doctor's visits, primary care doctor's visits in Florida. We're told that this is competitive. That makes some sense. It's competitive at least in the short run because there are tens of thousands of primary care doctors in Florida, I would imagine. So no individual doctor probably has a particularly large amount of market power. They can't just go in and say, I'm going to charge $500 when everyone else is charging $100. You probably wouldn't get much business. So we're told all of these doctors have the same costs, and their total cost function is TC as a function of Q is 10 plus 10Q plus Q squared. We're also told the marginal cost is 2Q plus 10. So the first thing I'm going to do is review some analytical equation-based things like how to find a firm supply curve, how to find a market supply curve in perfect competition, how to use that market supply curve and market demand curve to get a market price, and then you can go back and determine, are these firms making profit or is there zero profit, and we're in a long-run equilibrium. And these are just standard things you should be able to do just using the equations more so than the graphs, because the graphs are kind of useless for this. And some people find this tricky. This problem will also look similar because all the equations are pretty much the same as on problem set 5, question 12. So if you're getting deja vu, don't worry, you're probably doing things right. So first we're going to think about the firm's supply in the short run. The firm wants to maximize profit, so it's going to use our profit maximizing rule, MR equals MC. Because it's a price taker, its marginal revenue is just the price. We don't know what that price is yet, but it's whatever it is, we can denote it by P. If this was a monopoly, obviously we could not do that. And then we can plug in for our MC, that's 2Q plus 10. And this tells us, this is a rule basically that relates price and quantity. So it's kind of like a supply curve. If we wanted to graph it, we could graph this and call it supply curve, because when we graph supply curves, we graph them P on the vertical and Q on the horizontal. But usually we prefer to have it written as Q equals something, right? Q as a function of P equals something. So what you'll want to do is rearrange this equation and get QP equals P over 2 minus 5. That is your firm supply equation for the short run, with the catch that if the price is low enough, you'd want to shut down. So we're asked when would firms shut down, and the answer is if the price is below the average variable cost. It turns out this firm is not going to be shutting down in this problem, so we don't need to actually find out, what would be the minimum cutoff price for shutdown. That would be the min AVC, and we'd have to find our AVC and graph it and blah, blah, blah. I don't want to do that. So we'll just put like a caveat here, mental caveat that shutdown is always an option, and we need to check for it if we're in a specific situation, we had a specific price. Now, to get the industry supply curve, we need to think about if there's 12 identical doctors who are each supplying like the little q, then we want to multiply that little q by 12 to get the market supply, and that's going to be 6p then minus 5 times 12 is 60. That's our market supply. We're given market demand. Market demand is 100 minus 2p. So now we can set qd equals qs and actually solve and get a specific price. So 6p minus 60 equals 100 minus 2p. Solve for that, we get p star is 20, we get q star is 60, and then we can go back and plug this price into this guy here and find out what the little q is. So we plug that in, a price of 20, 20 over 2 is 10, minus 5 gives us 5, so the little q is 5. And finally, if the little q is 5 and there's 12 firms, then 5 times 12 should give us the big Q, the total amount produced by all the firms. And indeed, 12 times 5 gives us 60, and as we previously calculated, big Q is 60. All right, so everything's working out for us. This is fantastic. The final thing we're asked to do is to determine, is this market in long-run equilibrium? And that's pretty much code for asking, are we making zero profit? And in particular, our way for testing for zero profit is just compare P and ATC. So we know the price is 20. Now we just need to calculate the average total cost when firms produce 5 units each. So first we'll have to calculate ATC, get an equation for ATC. If our total cost is given by our equation up here, right, 10 plus 10Q plus Q squared, we can divide that guy, whoops, so our ATC down here at the bottom is TC divided by Q, so dividing that by Q, we get 10 over Q plus 10Q over Q, that's just 10, plus Q squared over Q, that's just Q. And now we can get our ATC star, ATC for the specific quantity of 5, so that we get 10 over 5 is 2, plus 10, plus Q is 5, gives us 17. So our ATC star is 17, our P star is 20. So this is not in long-run equilibrium. This is firms are making a profit, P is greater than ATC. We could calculate that profit, but it'll take too much time. I don't feel like doing that. And we know that firms are going to enter because of there's profit. So more doctors will move to the state of Florida, compete, get these higher prices. Eventually that will increase supply, drive prices back down, and we'll achieve some long-run equilibrium. So now we're going to draw some graphs and look at this graphically, but I'll need some space to do that. So can I get like another slide? Let's see. Yes, a new slide. All right, great. So we'll title this EMRs because that's our application is going to be to electronic medical records. And specifically, we're told to draw side-by-side firm and industry diagrams and then illustrate what would happen if firms are required by a new healthcare law or regulation, for instance, Obamacare or the stimulus bill, to make a one-time investment in new electronic medical record systems. So that's like a one-time purchase of some computers and software. And then we're asked what happens to the size of the typical firm, to the price, and to the number of firms. All right, so we'll do that later. First, we will draw our firm and industry diagrams side by side. So our firm diagram I like to put on the left, and that firm diagram is going to illustrate the firm's costs. For instance, it's ATC curve. Maybe we could draw an AVC curve. Definitely going to draw the MC curve and the MR curve if we know what the price is. On the right, I'll draw my industry curves. The industry is what we've been talking about pretty much all semester, right? This is the one that shows market supply and market demand, so we've drawn a lot of these curves, and I'm going to go ahead and draw them in. All right, so we have some supply here, some demand. The intersection of those two determine the market price, and then I can carry that over here. Sticking with the price from last time, let's say that this price is 20, and this quantity is 60. Since we knew earlier, we calculated P star is 20 and Q star is 60. So now I'm going to draw in my MC curve. Typical looking MC. I'll draw in my ATC, has a minimum where it intersects MC, and the price is 20. We carried over from here. So I'll draw in my price / marginal revenue is 20. And then I know where MC intersects that MR the firm is producing at that point. Specifically, it's producing 5 units. We know the ATC is 17. We calculated that. Also, notice how it looks like the point I've labeled on the ATC is its minimum. I mean, it pretty much looks like the minimum, which is right here, is about the same height as right here. So if this is 17, then maybe this is 17. That's totally wrong, right? Whatever the minimum is, it's lower than all the other points. So if we have another point that's 17, the minimum is below 17. It has to be less than 17. You can't say, well, they kind of look like they're the same, so let's just call them the same. That's more saying that you have a bad graph, that you're not a perfect artist, and none of us are. So that's just one way that graphs can be misleading. You don't get points for having a misleading graph and then drawing wrong conclusions from it, unfortunately. All right, so now we're told that we made this one-time investment in some new computers and software, and we have to determine, is that going to be a variable cost or a fixed cost? Intuitively, it seems like variable cost doesn't really fit. If I have 5,000 patients, I'll have to pay, say, $1,000 for the computer and the software. If I want to put 20,000 patients on the computer and the software, that's going to cost the same amount of money. I could put 1 million patients into the computer. If it's a halfway decent computer, I can pretty much get an effectively unlimited number of patients loaded into my database. So this is definitely a fixed cost. Since it's a fixed cost, it's not going to have any effect on VC, AVC, marginal cost, any of those things. It will shift the AFC curve if I plotted that, but I haven't here, so I don't need to do anything. And everything shifts our ATC, which is here. I forgot to label it, because ATC includes all types of costs, right? It's average total cost, so ATC is going to shift no matter what kind of cost changes. So we'll have the ATC shift up. The new ATC is, say, here. I'll call that ATC prime. And now we could imagine, what's going to have to happen in the long run to get back to a new long-run equilibrium, because now the firms are losing money. This ATC is way higher than it used to be. So one thing that will happen is, since firms are losing money, firms will exit. That will shift the supply curve to the left. We'll get some new supply, like S prime, leading to a new higher price. We'll draw in that new higher price over here. All right, that doesn't look pretty, but that's our new price and our new marginal revenue curve. And I've drawn it in so that P equals MC equals ATC all at this point here. That is the new amount each doctor's office wants to produce, and I'm calling that Q star star. And now we can determine what's kind of happening on the diagram. What has happened because of these new higher costs? One thing is that prices are higher, right? Because costs went up, firms were losing money, firms exited, it reduced supply and drove the cost up. That makes sense. We know in the long run our price is always going to be at min ATC, and if we had higher costs, that min ATC is at a higher point. Another thing we saw happen is we used to be producing 5 units per doctor's office. Now each doctor's office is bigger. They're doing Q star star. So in effect, probably what really happened is not so much that doctors quit and exited the market. It's more so that some of the firms have merged. So now we have bigger doctor's offices. Instead of having a whole bunch of little individual solo practices or maybe two-person practices, we have a whole bunch of doctor's offices with like 5 or 6 or 10 doctors each, and hence the Q star star is bigger. So that's pretty much all we were asked about: the price, the number of firms, and the size of the typical firm. The last thing we could ask from a policy standpoint is, what was the point of this policy if it's just going to cause prices to go up, and isn't that bad for the consumer? And the answer is, we don't really know what's happening to welfare on this diagram, because we know that the electronic medical record should be good for quality. So even though the price that you're paying for a doctor's visit is the same as before, you're getting a higher quality product. It might save your life, right? You might be really sick, and instead of, and they need information really quickly, and they can get it on the electronic medical record, whereas in the past they would have to, go through thousands of pieces of paper, and you'd probably be dead before they actually found your records. So even though you're paying a higher price, you might actually be happier and be better off with this policy. And that's definitely what the Obama administration had when they put this requirement in place. They thought it would lead to higher quality healthcare and save lives. So, you have to make the personal trade-off over whether paying a little bit extra for your healthcare is worth saving your life. Personally, I'd say it's probably worth it for me, but it's a judgment call. That's really something you're going to have to decide. And I guess maybe that'll influence you at the polls on Tuesday. There's 2 more videos in this series, so go ahead and check them out if you want to review monopolies and game theory.